Yes, so we are taking a derivative of a quotient of a function divided by another function, say h of x equals to f of x over g of x. Then the derivative of h is equal to the bottom function times the upper function minus the upper function times the derivative of the lower function, everything divided by the lower function squared. This is provided that the lower function, being a denominator, is not equal to 0, and of course that the derivative of g and f both exist. So suppose we have a simple function, say h of x is given to be 3 over x to the 5th. Okay, so we can think of the top number, 3, as our f of x and the bottom number as our g of x, and we take the derivative by first following this formula. So we multiply the lower function, which is x to the 5th, multiply that by the derivative of 3, or the upper function, which is 0, and subtract the upper function, which is 3, times the derivative of the bottom function, which is going to be, in this case, 5x to the 4th. And then we divide everything by the denominator, or the lower function, squared. So if I take x to the 5th and square it, that gives us, I'm going to write x to the 5th and then square it, and then we'll simplify it. Okay, so that will give us 0 here, and minus 3 times 5, which is 15, so it's negative 15 x to the 4th. Divide everything by x to the 5th square. In this case, we'll get x to the 10th. And we can simplify this further, which gives us negative 15 x to the 4th over x to the 10th. We subtract exponents, and we end up with minus 15 divided by x to the 6th. 10 to minus 4 is 6 in this case. It's not a very difficult problem, but let's try example number 2. In this case, we will have something of the sort. Let's say we have 5x over 1 plus 2x squared. Okay. Again, the lower function. So if we take this as our function h of x, this would be our f of x on top, then g of x on the bottom. So the derivative of h in this case would be the lower function, 1 plus 2x squared, multiplied by the derivative of the upper function, which is going to be 5, minus the upper function, which is 5x in this case, multiplied by the derivative of the bottom function. In this case would be 4 times 4x, and everything divided by the lower function squared. So in this case it would be 1 plus 2x to the 2, and we square everything. Okay, so we simplify a little further, distribute our numbers. We're going to get 5 plus 10x squared minus 5x times 4x will be 20x squared divided by 1 plus 2x squared to the 2. And if we carry it just a little bit further, we can see that positive 10x squared subtract 20x squared, we're going to get 5 minus 10x squared all over 1 plus 2x squared. to the second. Now it's possible we can simplify this, but it would not cancel anything on the bottom, so we're just going to leave it at that, like this. And we'll do another example, just for completeness. Let's suppose we take up something a little more complicated, example number 3. And in this case, we'll have that h of x will be equal to 2y plus 1. Wait, let's be consistent and stay with the same variable. Make it 2x plus 1 divided by 3x plus 4. Okay. Again, our derivative, using our quotient rule, we take the lower function, which is 3x plus 4, multiplied by the higher function, which is, in this case, it would be just 2, minus the the higher function, the upper function, 2x plus 1, multiplied by the derivative of the lower function, which is going to be 3, and everything divided by the bottom squared, or the denominator squared. If we simplify that, that gives us 6x plus 8 minus 6x minus 3 all over 3x plus 4 squared. Can we simplify further? Yes, 6x cancels 6x. 8 subtract 3, that gives us 5 all over 3x plus 4, 3x plus 4 to the second. As you can see, the process is not very difficult. You just have to be careful. There is room for mistakes, and keep trying.